Okay. First, in networking field, CCNA is a just basic level of um, basic level course. Okay, so to going to that next stream. Okay, so you have to learn that CCNA, Cisco Certified Network Associate. Okay, so this is exam, global exam for 120 minutes. Okay, the languages will be English and Japanese, and duration will be 120 minutes, and the exam cost is $300. Okay, so and fully it will be only MCQ questions only. They will be covering up, and as there is no lab for this. Okay, you have to do the lab practice also, but in exam, CCNA level exam, they won't ask about the lab and all those things, simulations. Okay, so when you go for that CCNP, of course they will ask the lab. Okay, so here only 1 mark question only, it will be, not 1 mark, it kind of MCQ questions only. So those who are going for DevOps, just leave it this career path. Okay. So those who want to just started as a CCNA fresher. Okay. Fresher. I just go through this path, how you have to go to the networking field. If you like this way, just go through it, or else go through your according to your way, just go through it. Okay. Just I want to tell that what are the path you have to go through that. Okay. So here. Okay, this is CCNA level. That exam number is 200,301. Okay, 200,301. And this is next. This is you will cover with that few of the topics. According to that, it will be divided over here. Okay, so here CCNP Enterprise is one of the topic. When you come to the CCNP, okay, these are the certifications. Here only they are bringing it to the types. Okay, so here you can't go for that after CCNA. You can go through this way also, this way also. That is enterprise level also you can go, or else service provider level is there, and data center level is there, and security level is there, and collaboration level is there. Okay, so whatever the level you want to go, this is must. This exam will be must. The first core exam will be must, and this concentration exam, any one of the exam you have to do it. Okay, then only you can go through that CCI certification. The CCI certification has 5 hours of lab and 3 hours of theoretical part. That means you can say designing part it will be coming. Okay, so this is totally it will be the cost will be 2 lakh around it will be coming. But here also for each certification you have to spend around 40K. Okay, so this is the CCNA and CCNP and CCIE level. So CCNA, after completion of CCNA, few of the people going to the cloud computing clouds also they used to enter, and few of them enter to the cyber security also you can go and join. Okay, so all of the things you should know about that CCNA. This is basic level of networking. Okay, then only you can do it. Next stream, you can choose the next stream. Okay. So here we are going to see about the topics. Okay, what are the topics I'm going to cover you here? So I'm covering here Cisco syllabus only. I'm just following the Cisco syllabus only. Okay. So here, yeah. Here are the topics. This is networking fundamentals. So they have categorized 6 topics. Okay, network fundamentals, network access, then IP connectivity, IP services, security fundamentals, and automation and programmability. Okay, this is totally complete. This is theoretical part only. Okay, so here the percentage also they have given. What are the percentage level they will be asking the questions. Okay, network fundamentals. What we learn here is first you will learn about the the function, the role and function of network components. Okay, so I'm not going to teach here. I'm just explaining what are the topics we will be covering here. From tomorrow onwards, I will start teaching. Okay, so here the main thing in networking we need routers, switches. So you know what is network? Okay, two or more devices or two or more communications. Okay, one place to another devices, we need a communications, right? So that is a network. Okay, so that to communicate we need a devices, right? To communicate we need a devices. So we have few of the devices there. Okay, so that we will learn here, that is routers and switches, firewalls, access points. Okay, and Cisco DNA, WC. This is controllers. Okay, this is controllers and endpoints, servers, power over Ethernet. This all you will be learning in the first day itself. Okay, and next you will learn about the topology, network topology. Okay, so that is 2-tier, 3-tier, spine leaf and WAN, SOHO and on-premise or cloud. Okay, so what you will learn here is, see that before going to build a house, what we will do, we will make a plan itself, right? We will go to the civil engineer and get the plan, civil architect. Okay, so they will give the plan. Okay, same way in network, you are going to install that routers and switches. We need a topology. Okay, so here how we have to make it and what types of topologies are there, all those things we will learn here. Next, compare physical interface and cabling types. Here you will learn about the cabling types. All the cables, it's not suitable for the networking. Here we have specific cables are there. Okay, connectors also there. So you will be learning about this cable and these types and all. Okay. Next, identify interface and cable issues. Here you will learn about the types of communications. Okay, so you can say that cable issues and collisions, errors, mismatch, duplex, okay, speed, and all these things you will learn about that. And compare TCP, UDP. This is transmission control protocol, user datagram protocol. That is main communications, how it's through happening. Okay, the protocols, these all protocols, we will learn about that. And configure and verify IP version 4 addressing and subnetting. Then this is main part. Okay, so so if you are living in a place, we need an address, right? So same way here also in networking, also in devices. Okay, so router using that addresses. Okay, so this is IP version 4 addresses. You will learn about the subnetting also. Here mostly we'll learn of the calculations only. And describe private IP addressing. So IP version 4, we have private IP and public IP also available. So we will be learn about that. And we have the IP version 6, because IP version 4, it comes to an end because that is full. It's already over. Okay, so through the NAT only we are doing the translation and all those things we are using for it. Now they are very little by little they are moving into the IP version 6. IP version 6 you can see in your mobile phone also, because Geo network started using the IP version 6. Okay, few of the ISP providers also start using the IP version 6 addresses. Okay, you will learn about that also. And this is IP version address types. Okay, and verify IP pearls. This is, you will learn about that wireless topic comes under that topic. You will learn about that. What is a SSD? SSID, what is encryption, all these things you will learn. And we'll learn about that virtualization fundamentals, virtualization containers and VRFs. Okay, so here you won't learn much this all you will learn in CCNP only. Totally you will learn in CCNP only. Here just you will go through just theoretical part only. And describe switching concepts. Okay, here you will learn about the switches. This is MAC address, frame switching, frame flooding, MAC address table, and all those things you will learn here. And network access. Um, okay, so this also comes under the switching part only. This is comes under the switching part only. Configure and verify VLANs, spanning tree, multiple switches, access ports. What is access port? You will learn about this. What is default VLAN? What is inter VLAN connectivity? And all these things you will learn. And configure and verify inter-switch connectivity. That is trunk ports. Why we are using trunk ports? Why we are using .1Q, this protocol and native VLAN? All these things you will learn here. And configure and verify layer 2 discovery protocols, that is CDP and LLDP. Okay, so this both protocol you will learn. See, you have a router. This is not a network, it is not a small topic, right? So in a network we have very wide ranges of devices are there. Okay, so you don't know next router where it is been connected and where it is located, you also don't know, and this port where it is been connected you don't know. So through this protocol you can find it. Okay, so CDP and LLDP will be learning there. And verify that ether channel, this is LACP and PACP also there, so you will learn that. So single, for example, through the single cable, okay, if it is going 100 mbps, okay, so what do you think? Sometimes if it is 200 mbps, that will be good, so increasing the bandwidth, how we can make it that uh, with the one single physical port, okay, making the multiple logical port, how we are going to connect with the multiple logical port to increase our speed. Okay, and interpret basic operations and rapid PBST spanning tree. Here it totally comes under the spanning tree protocol, SPT. Sorry. This is spanning tree. Okay, that we have a lot of switches. Okay, we have a lot of switches in our network. Among the switches, which switch is that um, master and slave? It will be choosing over there. So and avoid the loop also. We are going to use this concept, spanning tree protocol concept. Next, Cisco wireless architectures and AP modes. What are the AP modes? Okay, this all these things, access points. AP means access points. This all you will learn. Okay, and this is same. Describe physical infrastructure connections of WLAN components. Okay, AP and WLC access and trunk ports and LAC. This all you will learn. How we have to connect that AP modes. What are the use of that WLC mode and all those things you will learn. Okay. Uh, if you connect with that modem in your home, how will you do that? If it is wide range, that is, if you are working in an office, big buildings, how will you use it? That this all these things you will learn here. And this is telnet. Telnet SSH. This is protocol. This all protocols. This is network device management access. Okay, so router, we have a router and we have a switch also we have. Okay, so how we are going to access these devices? Through the through the telnet or SSH. Through that, these all the protocols we have. Through that only we are going to connect access this routers and switches, even though we have our firewalls, all these devices, we are going to use these protocols and we are going to take a connection over there through that. Okay, and console, this is TACAX and radius, this all this through the DNAC devices, through the devices. Here you won't learn. DNAC, it will be a separate course. You have to learn it. So through that you can take the access and interpret the wireless LAN GA configuration for client connectivity, such as WLAN creation, security settings, QoS profiles, and advanced settings. Here, totally we learn about the QoS, quality of service, and IP connectivity. Here, IP connectivity, you will learn about that interpret the components of routing table. So you will learn about then routers. Okay, in the routers, okay, how you are going to work it on. What are the things you will be learning here? About the routing table also you will be learning here. Okay, and prefix, networks, network marks, next hop, administrative distance, metric, gateway. This all this routers, and as we are going to use few of them for protocols, routing protocols, we are going to use it for it. Okay, to access the router we are going to use the routing protocols. There you will learn about that RIP protocol and EAGRP protocol and OSPF protocol. This three protocol topics will comes under that. Okay, and determine how a router makes a forwarding decision by default. Longest prefix match, administrative distance, routing protocol metrics, this all the same that comes under that OSPF, EAGRP protocol, how we are going to calculate the path. Okay, this comes under that only. Okay, and configure and verify IP version 4, version 6, static routing. Okay, this you will be learn about that routing, that is dynamic routing. This is default and static routing. Here you will learn about that. Okay, so where we are using, why we are using that routing protocols and all. Okay, and configure and verify single area OSPF version 2. Okay, this is the thing. OSPF version 2, here they have mentioned this is dynamic protocol where we are using. Okay, so to connect each other that network, we need a protocols to communicate to each other. We need a protocols for this. OSPF also one of the protocol. So what are the router election processes going to happen? What is that? This is DR and VDR. We will learn about it. And router DR, why we are using it, all these things we will learn it. And describe the purpose, functions, and concept of FHRP. Okay, this is first hop redundancy protocol. Okay, redundancy protocol means that is backup protocols. Okay, if that one place connection is going wrong, down. Okay, this is two routers are there. You are working here. Okay, you're just connecting the internet. Okay, so what happens? You are working through this router. Unexpectedly, this got down. So it should automatically connect through this router, right? So for this backup, we are going to use this protocol. How we are going to make it to be happen without any interrupt. Okay, and IP services, configure and verify inside source NAT using static and poles. Okay, so here we are going to about that NAT. Network address translation, this protocol, why we are using it. Okay, so already we are filled with IP version is over, already we are filled. Okay, and IP version 6 we are going to use. Okay, and another thing why we are using NAT is we are using private IPs. We are using our laptops private IPs. This private IP cannot routable with the public IP. So for this purpose, we need a translate. So this is NAT, network address translation. Through this, we are going to translate it. How we are going to do it? Okay, and NTP. Okay, NTP operating in client and server mode. So this is time management protocol actually. So how your system it's getting accurate time. Okay, so this is a network time protocol. Okay, and explain the role of DHCP and DNS within the network. So DHCP, already you might know that. Okay, so whenever your mobile Wi-Fi is on, that is mean DHCP mode is enabled. Okay, so if you see the settings, if it is enabled, wherever you go, your mobile automatically, if the Wi-Fi is free, your mobile automatically connected to that DHCP server. Okay, so that is what you will be learning here, how your mobile is fetching that IP. Okay, what are the process and all these things you will learn. And DNS, how our computer, when you are typing google.com, how your PC behind that, how it works, how it's fetching that IP address, this Google IP address, how it's connecting that. This all these things you will learn in the DNS. Okay, how it's going to from going go and take it from the DNS server. Okay, so it is kind of network domain address book. Okay, and this is SNMP network operations. Okay, simple network management protocol. You will learn about this. This is used for monitoring purpose. Okay, this is SNMP and syslog. You will learn about this. This protocol you will be using. You will be installing in your devices. Okay, in your organizations, in your devices. It will monitor all the devices. Okay, so for example. Your system is your one of the router is going to down, so it will give that alarm. Okay, so if you want to check that what are the problems, how it happened, all these things it will be recorded over there. Okay, and this is the syslog. Okay, and configure and verify DHCP client and relay. Okay, if your DHCP server in different network, how you are going to get the DHCP address, your IP address. Okay, all these things. And following per hop behavior for QoS, classification marking. Okay, see this is all this QoS you will be learning about how the QoS is working behind that. And configure network devices for remote access using SSH. Okay, you are sitting in Bangalore, and your device is in Delhi. You want to access it. Okay, you want to access it. So here, you each and every time you don't want to go. You cannot go and check your devices in Delhi. So instead of that, you're going to get the SSH access, okay, remote access. Through that remote access, you can see your devices. Wherever in the world you can set it there, and the devices which where it has located, through that SSH you can see your and monitor your devices. And describe the capabilities of function and functions of TFTP and FTP in the network. This is file transfer protocol and trivial file transfer protocol. Okay, why we are using it? Okay, mostly we are using in our offices. Okay, to transfer the files, storing the files, and kind of store that OS configurations and all these things you will be using for this servers. Okay, file servers. Just a minute. Next is security fundamentals. That is, here mostly we learn about the theoretical part of it. Okay, so when you learn about going for that CCNP level, there you will learn about the security separate concept. Okay, totally separate concept. Here you just go through that theoretical part only. Okay, so here that is threats, vulnerabilities, and exploits, mitigation techniques. Okay, this all this comes under the theoretical part only. Okay, and security program elements, user awareness and training, and physical access control, and configure and verify device access control using local passwords. Okay, this is totally password techniques. Okay, multi-factor authentication and all these things. And IPsec, this comes under the VPN. Okay, so how we are, what is the use of VPN and use of remote access and site-to-site VPNs. Okay, we'll learn about this and the access list. Totally, we'll learn about the access list. Access list is used for that. It is used uh, to you can say that filtering the upcoming and incoming and outgoing traffics. Okay, so we are going to create the access list. So this is you can say that through this list you can make this router as a firewall. Okay, so few of the organization they can't afford that firewall to buy a firewall. So in that time they will be using the router as a firewall. So through creating the access list, they can filter the traffics, ingoing and outgoing traffics. They can filter it and configure and verify layer 2 security features, DHCP snooping, dynamic inspection, and port security. Okay, this all those things you will learn. Okay, layer 2 security and authentication of the AAA. This is you will learn AAA, and this all the security protocols. Okay, so just theoretical part only. This both. Okay. Next, automation. This is totally different. Here only, this only will learn about it, theoretical part only. So automation is a separate topic. If I say that it will take around 30 through the Python, you have to learn it. Okay. So you should know that Python and JSON, few of the scripts you should know that. Okay. Through that only you can learn about the automation. Okay, so here through that only how that REST API is working and how that Ansible and Terraform we are using for that. This all the just basic theoretical part only you will learn about it. Okay, so these are the topics we are going to cover in the CCNA. Okay, so any doubt? So from tomorrow onwards, I'll start the classes. Okay, if you have any doubt, please let me know.
How many classes it will take to cover the complete course CCNA?
1 month. It will take 1 month.
Oh.
Yeah. If you are preparing for the CCNA global exam, you can take the dumps also from the internet. If you Google it, you will get it. You can prepare it that as well. Okay. So.
Okay. Any notes you can provide handwritten or
Yeah.
PDF notes?
Yeah, I'll provide a PPT.
Okay.
Whatever the topics I'm going to take, I have that notes already. I have it. I'll after the class I'll post it in the group.
Okay. Thank you.
Yeah. And do you have any question? Okay, just do me a favor for me. I need attendance. Okay. Okay. So we are going to see about what is networks and what are network components and what is topology and types of communications and types of domain and modes of communications. Okay. So this all these things we are going to see, but how much time? Because 7:50 or 7:55 I'll close it because 8 o'clock I have to start another session. Before 5 or 7 minutes I'll be closing that. So till that I'll try to finish this or else tomorrow I'll continue. Okay. So how much it's taking time, I don't know. We'll see because it is around it will take around above 1 hour sometimes. So we'll see that. Okay. What is network? A network is a system that connects two or more devices, such as computers, phones, allowing them to share resources, files, and to communicate with each other. Okay, so normally a single system cannot be a network, right? So two or more devices, okay, single system cannot be a you can say network, okay. So in a one place, okay, in a surface, if you have a multiple devices, okay, if you have a multiple devices, we are connected, interconnected with each other, that we used to say a network. Okay, so we need in the network, we need some devices, that also we are going to see, but we are going to see that what is network and what are the types of the network. Okay, and here we have the types of network. Only I have mentioned 4 types of network, but if you go through the Google, you can see a lot of types, you can see it. Okay, so main thing we are going to see this many only now. Okay, this is PAN area network, sorry, personal area network, PAN, LAN, local area network, then metropolitan area network, then wide area network. There is 4 types of networks. Okay, here PAN area network means, sorry, PAN means it's a smaller network. You can say that inside your home, you are using not only mobile. Okay, in a modem, you will be connecting mobile. Okay, in your family, how many members are there? You can connect 3 or whatever the number. You can connect lot of number of mobiles, and tablet. If you have a tablet, you use to connect, and devices. Okay, laptop within the 10 meters. Okay, so that is, you can say, within a few meters. Whatever it has been connected, we used to say this is personal area network. This is minimum, that is within a few meters of each other, that is minimum 10 meter. Okay, so that is PAN, personal area network. Okay, so LAN means, when we consider it, if you are working in a place, okay, so for example, this is school, you are working here, so here we have few buildings are there. Okay, each building will be called as a LAN. Okay, so a LAN is a type of network where devices are connected with each other and within a limited geographical area, such as a home, office, or school. LAN are usually implemented to allow computer sharing or centralization of resources such as printers, files, and the internet. Okay, so within that area, okay, so this we used to say call as a LAN. Okay, this we used to call as a LAN. Here we can connect printers. Okay, so whatever that devices you can connect that in that in this surface only, not to the other side. Okay, if you connect this LAN to LAN, that will be different. Okay, this is separate. So this is local area network and metropolitan area network. This is MAN. This is group of LANs. Okay, several LANs we can connected interconnected with each other, that is MAN, metropolitan area network. Okay, MAN is used to connect several LANs together, and thus it extends over a larger area, usually a city or a large campus. Today LANs are combined by many organizations using MANs. MAN is a bigger than you might think. It can cover a whole town. Universities implement MANs because they link all the buildings. City governments use them too. Okay, so what they are telling that in the cities, okay, in the cities, okay, for example, you can see government offices, lot of government offices are there. Okay, so each government offices is a lab. Okay, so it was in separate places, but if you go there, they have that interconnected to the other offices. Okay, they have interconnected with the other offices. This is we used to say call as a metropolitan area network. Okay, for example, in a city, ABC school was there. Okay, in one place the ABC school was there. Okay, this is one town, you can say. That same city, another town, another ABC school is there, the same branch. This is LAN, you can say. This is LAN. So wherever the ABC schools are there, they have been interconnected. This is we used to call as a MAN, metropolitan area network. They have interconnected with each others. Okay, and wide area network. This is globally, you can say, connected with MAN. Okay, So WAN connects a large geographical area and can extend to several cities, regions, or even countries. WAN are largely employed in large organizations to interconnect a number of LANs or MANs. The internet is actually the biggest WAN out there. Companies with offices everywhere need WANs. Banks use them to connect branches. The data travels long distances, sometimes through underwater cables between countries. Okay, so what they are telling is, so for example, here in India we have lot of TCS companies there, right? TCS offices or a lot of places is there. Okay, so main cities you can say Chennai and Mumbai and Bangalore, all the cities, all over the cities they have covered. Okay, so this is, if you come to the Chennai, this TCS, this is, you can say LAN. Okay, if you connect with the Bangalore, that is a MAN. Okay, if you connected with that, if you, that company is in UK, if it is connected with that, that will be a WAN network. That's it. That's globally it has been attached. Okay, so here I'll show that. um, so this is how it looks. It's connected through the sea, under the seas. Okay, so this is, this cable, fiber optic cable they used to connect with that from here to another locations. So here it look like this, the map will be like that only. They have connected, the cable goes through the underwater only. Okay, so this is WAN. Okay, so okay, that's over. So we have seen the network types, we have seen it. Now we need a devices to connect uh, from PC to, we need a communication. So we are making a we are going in a network. We need a devices also. Okay. So in this device, what are the devices we are going to use it in a network? Okay. So which devices are communicating to each other? So which protocols we are going to use? This you will learn upcoming classes. But we need a devices to connecting one place to another place. We need a devices, that is the hub. Okay, the first is hub, then switch, router, modem, server, firewall, and access point. Okay, so hub, what is the use of hub? This is, you might have seen in your home also, in your offices also, small offices they have used the hub. Okay, so how hub it will look like this only. It's a dumb device only. Okay, so whatever you are sending here from the internet, okay, so whatever you are sending here, just it will forward to the devices. Other than that, it won't do anything. Okay, so it's kind of dumb device only. Okay, a hub is a physical layer networking device which is used to connect multiple devices in a network. They are generally used to connect computers in a LAN. Okay, so so mostly they will be using for that learn network. They use this hub device. Okay, so they can connect each port. It has a port, so you can connect it here. So once the communication is cut here, so everything will be off only. There is no other communication over here. Okay, so this is hub and this is switch. So this is advanced. This is switch is very intelligent device. Okay, so this is layer 2 device. You will learn about what is layer 1, layer 2. Upcoming classes you will learn about this. But normally I used to say this is layer 2 devices. Okay, this switch has 24 ports are there. Okay, this is 24 ports switch. If you search in Google, it has 48 ports also. It's there. This is biggest data center they will be using for this switches. Okay, so normally this is 24 ports. So, but this switch is intelligent device. Okay, it will broadcast the messages. Okay, it will broadcast the messages. It has the, it few protocols are there, but hub doesn't have the protocols. It won't broadcast the message. It just whatever the messages it's receiving, just it's sending that, send it there. That's it. But switch is not like that. It is an intelligent device. It will broadcast. It has the protocols. It has the security protocols are also there. Okay, so we have lot of things learned. We have to learn here. Okay, the network switches a technology that allows two or more IT devices, such as computers, to communicate with each other, forming a communications network. Switches enable devices on the network to share IT resources such as printers, servers, etc. Okay, so mostly where we are using. So LAN connection, okay, in a small office is there, okay. So here one person is working, okay, but the same thing, lot of person is working here, okay, lot of person is working. Each device. Okay, so they need a communication, they want to communicate each other. What they will do? They are going to install the switch over here. So they will be connecting, each one of you connecting here. So what happened? Now they can communicate each other. Now they can communicate with each other through the switch. The communication will be happen. The LAN settings, they will be using the switches because this is same network. This is same network inside it. For example, here they want to connect this firewall also, they can connect it. Any devices, the switch can connect it. And routers, okay, whatever the device you want to connect, here server, here the switches, through switches you can connect it. But here within the communications you need a switch. Okay. Okay. Then router. Okay, so router is a device that forwards data packets between computer networks. It is used to connect devices between different local area network. It sends data traffic based on IP address. Okay, switch use, okay, it will use the MAC address. Switch uses the MAC address. According to that, it will have the communication. But router, it has the IP address. Router has the IP address. According to the communication will be happen. The switch we have used, switch here. Here you have a PCs. Okay, so everyone has been connected through here. Okay, okay, everyone has been connected. This switch. Okay, here another LAN is there. Okay, here another LAN is there. Now this is school, for example, this school campus. Okay, this is science department. Okay, for example, this is science department, this is computer science department, but this is functional, actually it's functions separately only. But you people want to connect each other, this people want to communicate with this people. So what will you do? You cannot directly connect here. You can connect if it is same network. If you are using same network, you can connect. But I'm using here different type of IPs. I'm using here different network. Here I'm using different network. Okay, so what I'm saying here, for example, you will learn about the IP addresses also. 192.168.10.0 series I'm using here. Okay, I'm using this network. I'm using here 10.10.10.0 network I'm using here. Okay, so two different networks can communicate with the routers only. Through the routers only, you can communicate the different networks. Router is using for that. For example, if it is the same network, I'm not using this network, I'm using the same network only, 192.168.10.0/24, the same network I'm using here. Suppose I don't need the router, only switch through switch I can communicate. Okay, if it is the same network, there is no need of router. If it is a different network, we need a router. Okay, that is what here they are mentioning. Router is also very intelligent device. Okay, according to the, if you have so when you have a router, you have to give the protocols. Which protocol are you going to use to communicate here from here to here? So according to that, it will find the path. It will determine the path and choose the best path to reach from here to here. Okay, so all these things you will learn about the router and routing protocols. You will learn about it. Okay, so this is intelligent device. Okay, so okay, based on it, it will base working based on IP addresses only. Okay, next is modem. A modem is a device that allows computers, smartphones, tablets, and other devices to connect to the internet. As we know, in our home we are using modem. Okay, so through the modem only we are getting the Wi-Fi signals. We are using all the devices. Okay, so whatever the device has that Wi-Fi, we are using the through the modem only we are using it. It does this by converting signals, digital signals from these devices into analog signals that can be transmitted over telephone lines or cable networks. Okay, while you are getting the your modem will be connected to the router. Okay, so through the cables only you have been connected. Okay, from inside your home only, if you want to LAN cables, you can use the LAN cables for your PC. Okay, if not, you can use the Wi-Fi. Okay, that is the use of the modem. Then server. A server is a system, either hardware or software, that serves resources, data, services, or programs to computers called clients over a network. Okay, so what is server? Actually, this is, we can say that hardware also and software also. Okay, so if you are using that AWS and what else, Azure, if you are using that, that is software servers. Okay, so hardware servers is you can see in your office. Okay, so that is the big devices it has, it contains. Okay, it has a biggest storage capacity is there. Okay, so all that the server also will be differed each and everything. Okay, DNS server is there, DHCP server is there, and Google server is every part. Okay, we have a server. Okay, so according to that it will work. Okay, so resources, data, we can store the data also. Okay, and services or programs to computers over a network. Mostly in your office they will be using the servers. Okay, so the n number of datas, everything has been stored in their server only. They won't allow to store in your PCs. You have seen it. For example, once you have joined in a company, they will give the access. Okay, they will give the laptop or else PC. You can use your server in the office server only. You can use it, and there you can store the data and you can do all the things. Okay, and firewall. Firewall, it is a network security device that acts as a barrier between trust and untrust environment. It monitors both incoming and outgoing traffic based on policy created. Okay, so what is a firewall? Okay, so firewall also, it's a hardware firewall, also it's there, and the software firewall also there. Okay, so hardware firewall, if you see that in a biggest company, they can afford it. It is quite costly. Okay, so they can afford it and they can install. Okay, for that is also, if they have about thousands of employees, they will be using for the hardware firewall. Otherwise they will be using for the software firewall also. So you also using the firewall in your laptop, right? That is McAfee, this all the softwares you have uploaded it. Okay, for that safety purpose, that is that any attacker should not come to attack our files. Okay, that is the purpose we are using the firewall, right? So same way here, hardware firewall also companies are using if they can afford it. Okay, so where they will be installing it, okay, through the internet, and this is office, your LAN office. In between they will be installing the firewall. Here what they will do, this is untrusted place. Okay, This is untrusted environment. This is trusted environment. They used to say this is trusted environment. Okay. The communication. Okay. So whatever the communications they are doing from here to here. Okay. So what is that? They are doing the communications. So suppose in your office, the people sometimes they may click any of that unused files. So what might happen? The virus can be attacked. So what will happen? This firewall, okay, so it will check that all the data, all the incoming and outgoing data, everything it will check. So once the person clicked, it will that return the traffic. So what will happen? This firewall will check whether that data is purity or not. Okay. So it will check the integrity of the data. Then only if it is good, it will allow, or else it will be blocked over here. Okay, this is the use of that firewall. So we can make a policy according to our will. For example, in your office, most of the office you cannot use the social medias. Okay, most of the office they have blocked it. Through the firewall you can block it, but you can do the Google and ChatGPT, all the things you can do, but you cannot uh, of the social media, because already they have made the policy. Through the policy only they have blocked the all the social medias. Okay, so this is the use of firewall and wireless access point. Wireless access point is a networking device that allows wireless capable devices to connect to a wired networks. Okay, so wireless access point, it is used to control all the access point. It is used to control all the access point. Okay, so for example, here, okay, uh, okay, here this is not WLC, wireless access point. Okay, so this is you can say like that. What is that? You say that modem, kind of modem only. Okay, here you can allow wireless capable devices to connect a wired network. Okay, in the wired network you can allow the wireless capable device, that is it's kind of Wi-Fi router. It's kind of Wi-Fi router. You can connect each and every devices through the wireless. Okay, so and another thing also you can say that this through the wireless access point. Okay, uh, if you are using single access point, okay, you can use it handily easily you can handle it. Okay, you can say that how many devices you can connected it, everything you can check it there. Okay, for example, in a building, okay, in a building each floor has the access point, that is kind of router only. Okay, that is wireless router only. So this is each floor you have a access point. So what will you do? Each floor, how many devices can attach? You can see it. But each and every time you cannot go and check the access point and doing the installation and add the device and all these things. Okay. So for this, you can use that WLC is there. Okay. Through that, you can see this is kind of one place you can check all the access point, activate all the access point. You can monitor from here, so you can see here from what are the devices can be added, when you can delete the devices also. Okay, so for example, unauthorized devices can become here, come here also. So that time they also start using the internet, so you can remove it also through the WLC. Okay, so this is wireless access point. And differences. Okay, so we have differences between hub, switch, and router. Okay, so hub is this is according to the OSI layer. Okay, we have OSI layer as 7 layers we have. Okay, in OSI model we have 7 layers. This is physical layer, comes under the physical layer. Hub is a dumb device only. Okay, so it won't do any of the function. Okay, Just it will receive that traffic and will pass it to the devices. That's it. So this is comes under the layer 1 device. Data link layer. This is layer 2. Okay, layer 2 is a data link layer. This is switch is a data link layer. And layer 3 is a network layer. Okay, router works on layer 3 only. Okay, and function, what is the function it will do? Broadcast data to all the ports. Okay, so here what is happening, already I told you, whenever the internet, from the internet your hub is just forward the broadcast the data from here. How many devices are there? It will just broadcast the data. That's it. From here to broadcasting the data. Oh, that's it. Okay, whatever the ports it has been connected, it will send it. That's it. Forwards data based on MAC address. It will check the MAC address. Okay, so for example, this is switch. Okay, here PC1 has been attached and 2, 3, 4. You want to communicate to PC1 to PC4. What will see? It will transfer the data according to the MAC address only. Okay, MAC address only, and forwards data between different networks based on IP address. Here already I told you the routers works based on IP address only. Okay, here MAC address table, there is no MAC address table. Routers switches using maintaining the MAC address table. Here also it won't maintain because here it is using MAC address. So according to that it will use the MAC address table. Okay, so here the router maintains the routing table. The router maintains the routing table. According to that, it will forward all the data. Okay, here there is nothing. Okay, and traffic control. This is uncontrolled. Whatever the data is sending here, just it will throw it out. That's it. Here it is controlled. That is unicast, multicast, broadcast. You will learn about the communication types over here. Okay, so this is controlled. For example, you want to send the data from 1 to 4 only, you can do it. This is 1 to 1. You can say unicast. But we want to do send that all the PCs should receive my data. You can send that to all the data that is broadcast. From here to you can send all this data to that all the devices that is broadcast. You can do it. This is according to the MAC address only. It will do function it. Okay, and controlled based on routing tables. You can route the this router will you can control it based on the routing table. It will function it. Okay, from this we have the router. Okay, here this from this router to okay, this router I want to reach here. This from A router to B router I want to reach here. So if you want to go this way, you can write the program over here. Okay, you can give that configuration. According to that, it will work. Okay, if you are blocked this way, it won't pass it. We have two options, going this way also, this way also we have. But according to the routing table, which way you have configured, according to that only it will send the data based on the routing table. It will check the routing table, which route they have been configured. According to that, it will work. Okay, then bandwidth. Shared bandwidth among all connected devices, dedicated bandwidth per port, dedicated bandwidth per port. Okay, so we have if we have a device, okay, so what will we do? We have that every device have dedicated bandwidth. According to that only, it will send and receive the data. Okay, so here in hub there is no dedicated bandwidth. That is normally it will send all the devices. That's it. Okay, according to the bandwidth only, it will send and receive the data. And intelligence, this is least intelligence, this is more intelligence, this is most intelligent. Okay, and network expansion, not suitable for larger networks. Okay, so this is not suitable at all. This is suitable for larger networks, essential for connecting multiple networks. This is we can use for the large networks. Okay, so we have 24 ports. Okay, in switch we have a 24 ports. 24 ports are there. Okay, so I want to See, 24 device only we can connect, right? From any one of the port, you can connect another switch. From here, 24 port. So you can extend your networks very bigger level, not a small level. Okay. So according to that, it will work. This is suitable for larger networks. This is connecting multiple networks. That's already I told. A router can connect. Okay. So here one network is going and here another network is going. Okay. Multiple networks. You want to connect this network to this network. Through that, this way you can reach it. Okay. So largest network, we can multiple networks. You can say that multiple networks, we can connect it through the router. Okay. Next, topology and types. Okay. So what is topology? Okay. So for example, when you are going to build a house, you will make a plan. Okay. Then the architecture will make a plan. Then he will give it to hand over to you. Then what you will do? You will find out the engineer, good engineer. Then the plan has to be executed. Okay. The same way the engineer will find out they have labors and they will start purchasing the materials and they started working here there. Okay, so same way here also the topologies are there. The topology is defines the structure of how all the components are interconnected to each other in a network. Okay, topology, that means, okay, in a school, okay, in a school you are going to uh, install the devices. They are asking that we have lot of buildings over there. Okay, in a campus we have lot of buildings over there, but we want to connect from this building to that building. So every what are the devices we need to purchase and how we can get the internet connection, all these things they are asking to you. Okay, then what the network architect will do, they will do the some estimation first. Okay, so they will make the first topology. Okay, how many floors are there? Okay, in a school how many floors are there and how many which places what are the places they have installed the PC. Okay, sometimes the fourth floor they may not have the PCs and third floor they may have the PCs. Okay, here what are the devices they have to be attached, how many devices they need it. So all the plans first they will find out the devices, how many where they have to be installed, all the devices. Okay, how many switches we need, how many routers we need, okay, how many hubs we need. So all the things they will uh, gather it, then they will make a topology. According to the topology only they will arrange the devices, install the devices. Okay, so 7 commonly network used topologies are, okay, so point to point, bus topology, star topology, ring topology, mesh topology, tree topology, and hybrid topology. Okay, so we are going to see what are the topologies, how it looks. Here, point to point topology. Okay, the point to point topology is a type of topology that works on the functionality of the sender and receiver. This is only one to one. If you have a device, two device, you have a LAN cable only, that's enough. Okay, so from here to you are sending here, that is high bandwidth. Okay, there is no interruption, nothing else. Okay, only sender and receiver. This is point to point topology. Okay, next bus topology. Okay, so this is main advantage and disadvantage we have. Okay, so where they are used in simple setups where a few computers are connected to share files or printers. So we can say in a small LAN, not a big. Minimum around 10 to 15 devices if they have, they can use the bus topology. Okay, simple to set up and cost effective. That means single cable they have connected with the multiple devices. Okay, so simple to set up and cost effective, well suited for small networks with few devices. Disadvantages is limited scalability, adding more devices can degrade performance, a single cable break can disturb the entire network. This is that through the single cable only you have been connected every devices. Okay, in other way I can explain it, not another way I can explain it in a network. Here is the router. Okay, here is a not a router. I'll use the switch. Okay, here switch is there. Okay, in the switch you have connected multiple devices. Okay, here another switch is there. Okay, here also multiple devices you are using it. Okay, here also you are using another switch. Okay, so here also using few of the devices. So this is, we can say, that bus topology. So through the single cable you are connected each and every one. So what happens if the interruption from here, you have network, you have attached here. Okay, so what is happening if it is any interruption happening here, remaining everything, whatever the devices has been attached, everything will be cut. Here this one only get that connectivity. Okay, so this is the disadvantage. Okay, there is no other way to reach here. Okay, once it rectified, then only you can reach it. You have a communication. So this is the disadvantage bus topology. But this is also very low bandwidth. Also, you will get whatever the device is nearby, you will get the high bandwidth. That it will go on here. What will happen? There you will get the very low speed connection. Only you will get it. Okay, and star topology. This is advantages is easy to install. Okay, it look like that only. Okay, with the switch you have connected each and every devices you have been connected. Okay, so in this easy to install and manage and troubleshoot. Okay, it is easy to install. If you want to connect, you can directly connect to the switch and you can start work. Okay, work over here, and isolates the issues to individual connections. A failure in one device doesn't affect others. If it is any failure is happening, this device only will be cut. Okay, it will remove from this. Okay, other devices there is no effect, nothing else. As usual, it will work. Okay, so that is that. But this is one disadvantages also it's there. Okay, so dependence on the central hub, if it is fails, the entire network goes down. For example, here you have connected the internet. If it is happening anything interruption happening here, the entire network will go down, and else more cabling is required and making it costlier than a bus topology. Okay, so each device has a cable. So here they have mentioned very smallest area they have given. Okay, for example, one device is distance from 100 meters, one device is distance from the switch to another 50 meters. Like that, if you connected like that, you have to buy a lot of cables. Okay, so this is very costlier. Cables also it's not easy. That is also very costly. So this is the disadvantage. And ring topology. Ring topology is look like this only. Okay, for example, I'll show here. Here is a router, here also router, and here also router. You have connected this four router. This is ring topology, comes under the rings topology. Okay, so even data distribution as each device has an equal opportunity to transmit. Okay, so this is equal transmit. Okay, so this way also you can send the data, this way also you can send the data to this router. Okay, so anyway this is equal opportunity to transmit the data. And simple and predictable data path, you can predict the data very easily, where the data is, which way is going here and which path is going down. You can rectify it easily, find out the problem easily. And disadvantage is a break in the ring can disturb the entire network. Okay, what will happen here? This router 2, you have given this path only, this path only you have given, you didn't give the alternate path. What is happening now? This path has been interruption happening. So what will happen? You cannot, because already it's gone, you cannot reach this router, you didn't give that another path. Okay, so the entire router it's getting, and you cannot get the connections. Okay, so this is disrupt the entire network, and adding or removing devices can be complex. This is also, now if you want to add that one of the devices over here, okay, what you have to do, you have to shut it down all the devices, then only you can attach here. So this is interruption. Okay, so this is very complex also. Okay, the downtime will be increasing. And mesh topology. Okay, this is mesh topology is each node has been connected with each other. Okay, so high redundancy network remains operational even if some connections fail. So we have redundancy here. Okay, so for example, this node 1 I'm connecting here. If this link goes down, I can reach this node 3 through this way also, and through this way also I can reach through a N3. So everyone has been interconnected each other. We have lot of redundancy here. Okay, redundancy means backup. You can reach at any through any path. Okay, and scalable and adaptable can handle a large number of devices. You can handle the large number of devices. Okay, but the disadvantages is we in device we have sometimes 4 ports to 8 ports only. Okay, if it is a big network, you cannot do that, right? The ports, we need a large number of ports. Okay, it won't support. And large number due to the expensive due to the numerous cables and ports required. We need lot of cables also. It is so expensive. This is disadvantage. Okay, and complex to set up and maintain. Okay, it is very complex. Okay, for example, you are finding this cable where it's going. Here in diagram you can see it, but the real life, if you see that, you are sitting here. Okay, yeah, if you go to see the rack in Google image, if you see the Google image rack, okay, switch rack, it will be collapsed. Large n number of cables will be there, but you don't know where the cables it's going through, right? Which device it has been attached, right? So this is very complex. Okay, setup and maintenance very complex. Find out the cables, how many cables you have connected. Okay, you have in the network. We can find out. How we have to find out? This is how many nodes we have. Okay, in this topology, how many nodes we have? We have to calculate it. Okay, for example, 1, 2, 3, 4, 5 nodes we have, and 5 into 5 minus 1, 4 by 2. Total 10 cables are there. This is the formula of to finding the cables. This is mesh topology. Okay, so these are the topologies, and remaining 2 or 3 topologies are there. You just Google it and learn it. Same thing, only they will be conjoined over there. Okay, so from here, types of communications, I'll start from tomorrow. Okay, if I start taking here another 15 to 20 minutes, it will go. Okay, so this is that from types of communication and domain. Okay, and modes of communication. Tomorrow we will see. Okay, do you have any doubt till this? Hi guys, good evening.
Hi, good evening.
Hi,
Good evening.
good evening. About what is networks and what are the topologies and all these things we have seen it and what are the components. Okay, so today we are going to see about domain. Sorry, first is types of communication. Okay, what are the communications among that devices? Okay, that's what we are going to see, because we are going to use that routers and switches, all these devices we are going to use. So in this, what are the communications types we have? So this is what we are going to see. Okay, we have four types of communication types we have. Okay, one is unicast. Unicast. Yeah, unicast is one-to-one communication. That means if you have a here just see this. This is sender. Any one of that person will receive. That means here the sender only having only one address, only one communication, not this other devices. Okay, so one-to-one communication is a unicast. Okay, multicast is one-to-many communication. That means they may have lot of devices in the network. Okay, but those who are available in the network, they only will receive the messages. They only will receive the messages. Remaining will be silent. Okay, they won't receive the messages because they are not available in the network. Okay, so this is multicasting. And you can say, for example, in YouTube, few of the tutors are teaching the lessons. Okay, only few videos you can see. Okay, few of the videos you cannot see. Why? They have given that one option is only for subscribers only. Okay, they kept the subscriptions only. Okay, so that means the subscribers only available to see the messages, see the videos. That is multicasting. That is already available in the network, or else you can say subscription in the network. Okay, so that people only will receive it. So one to many communication. Broadcast, already we know that one to all communication. So for example in TV, that for example in TV IPL matches are going on, and a few of the matches, if it is happening, what will you say, what will we say? So that they started broadcasting. That means doesn't mean that they are opposite side, they are available or not. Okay, so the sender one starts sending the message, everyone receive it or not. That's it. So this work is to send all the people. That's it. Multicasting, broadcasting. Okay. So one to all communication. Anycast is more than one node will have the same address and message will be delivered to the nearest node. Okay. So this is, for example, in a hall you are sitting here. Here lot of people are sitting there. Okay, here lot of people are sitting there. So for this person name is what you can say, this person name is Raj. Okay, so here also last row also name is Raj. So this person calling this name Raj, the one who's sitting near, that person will hear. The one who's sitting near, that person will reply it. Okay, so that is what here any casting. This person didn't hear it. Okay, so first those who, the one who hears and reply it, the person will deliver the message. Okay, so this is any casting. So more than one node, the same name, they may have lot of people there. Okay, so one is the nearest one, they will be receive the messages. Okay, so this is Unicast. Because why we are using this term, when we start using dynamic protocols and routers, routing protocols. So when we start talking about that, we start using this word. Mostly this broadcast and unicast, this words we start using this. Okay. So for this reason, we have to learn. That means one broadcast means one to all communication. Okay. Domain. And we have domain means already okay, so that for example if you are studying in a college, so a few people ask you which department you are. Okay, so for example, you may say that I'm CS department and EC department and all these things you may say. But the thing is, so if you say that we can say that domain also, which domain you are. Okay, so that IT domain. So according to that, the group administrative grouping, you can say the name. Okay, so a network domain is an administrative grouping of multiple private computer networks or local host within the same infrastructure. Okay, and example, and if you are working in a company, they will ask that which domain you are working. So networking domain or software domain or hardware domain, they may ask like that. So particular group. Okay. So types of domain, we have two types of domain. One is broadcast domain, another one is collision domain. So broadcast domain is network or part of network where a node can use a broadcast message to deliver message to each and every other node in the network. Collision domain network or part of network where there is a possibility of collision when there are the two or more nodes are communicating at the same time. Here is an example I'll show here. Okay, here you have a router. Okay, this is another network. This is one network. This is another network. This is second network. Okay, so when the router receives the message, receive the messages, it start broadcasting over here. Whatever that link has been connected to this router. Okay, so from this router to switch we have connected. Here also switch we have. So once that router receives the message, it starts broadcasting. So this means we say that broadcast domain. This is called broadcast domain. That means once the switch receives the message, it starts sending to all. It starts sending to all. This is we called as a broadcast domain. Here also same. Once that switch receives the message, here it's sending broadcasting to all the devices. Okay, collision domain is okay. For example, in a hall, one person is talking. You are all listening. That is broadcast domain. Okay, for example, the person who is talking and other people are receiving. That is broadcast domain. Okay, so collision domain means this person also talking and those who are sitting, all of them talking that simultaneously. All of the people are talking. So that what is happening? No one can hear this person's voice. No one can hear other person voice also. So what is happening? There will be a clash and boom. So no one can hear any other's voice. Okay, some clashes are happening over there. Okay, same thing here also it's happening. Okay, so broadcast domain is once it's receiving, here it's happening. Okay, it's sending to all the devices. Okay, broadcast domain. Okay, so collision domain is once it has received. Okay, so it has received, it's also sending the same messages to the other thing also. The traffic is getting high. Okay, so this is happening. What is once the traffic is heavy, the congestion is starting here. What is happening? Something happening, clashes. Okay, so everything is gone down. That is collision domain. Okay, so this is the mode domains. Okay, types of domains. We have broadcast domain and collision domain. Okay, for example, broadcast domain means, and another thing is, if here anything problem is happening, everything will go out. If the link is down, everything will go out. Okay, so collision domain also here like that only. Here this opposite side also it starts sending and receiving at the same time. Collision is happening. Okay, so collide, it start colliding each other. So it's gone. Okay, and modes of communication, we have three modes of communication. One is simplex modes and half duplex modes and full duplex mode. Okay, so simplex mode is only one direction. Okay, for example, this is FM radio, only one direction. You can hear that only. You cannot send that. You cannot talk. You cannot send a message at the same time also. You can hear only one side communication only. And half duplex mode is walkie-talkie. You can say that the policeman using their in their hands. Okay, so how it's half duplex? You can explain it like that. Okay, this direction. So, for example, this is policeman one This is policeman 2. Okay. Once he sent the message, okay, once he delivered the message, what he used to say? Over. Once the over is stopped, then this person start talking. Then this person after his message, what he is to say? Over. Then this person will talk. This is off duplex. Only one person send a message at a time. Other person has to wait. Okay. The same thing is happening in the devices also. At a one direction, once it's sending the message, it has to receive. Wait. Once it received, then it will send that acknowledgement, or else it has to send the data. Like that only the communication is happening. Okay. And another thing, this is another third one is full duplex mode of communication. For example, phone call. Okay, this is both the sides. We can talk, we can send and receive the message at the same time. For example, when we call to a person, the same person opposites one side, we ensure that he received the call. Then what we started is to talking, that person also started to talking. Both the person communication has been started. That is full duplex. At the same time, we can deliver the data. Okay, this is the modes of communication. And next is we are seeing about cables. Okay, so first 1 week that classes will be very theoretical only. After 1 week, we have started the lab also. You have to download packet tracer for the simulations. So once I start teaching here, you also try to do yourself. Then only you will understand the concepts very well, very clearly. Okay, so I'll teach you how to download the packet tracer and all. Okay, so till 1 week, the classes will be fully theoretical part only. Okay. So next is cables. Okay. Uh, we have a lot of cables, but in networking we have few of the varieties of cables are there. Okay. So we are going to see what types of cable we are going to use. Okay. So what is network cable? A network cable is a physical connection medium used to transmit data and information within a network. So mostly what is the purpose we are using? To send and receive the data. Okay, so usually made of metal or glass. It is a cable used to connect computers and other network devices and connect these devices to the local network. Okay, to connect the other devices, we need a cables. Okay, here we are using Ethernet cables. Okay, so this cable combine we have two categories. Okay, so one is copper cable and fiber optic cable. This copper cable comes to two category. This is twisted pair cable and coaxial cable. Okay, this twisted pair cable comes to two category, UTP and STP. This is unshielded twisted pair and shielded twisted pair. Here, the fiber optic cable comes to two mode. One is single mode and multi-mode. Here, this is that uses. Okay. So, fiber optic cable, single mode and multi-mode. That's it. So, we are going to see each and every cable, how it works. So, twisted pair cable. So, twisted pair cable, this is the one. Okay. This is twisted pair cable. So, twisted with the their own pair. This is white orange. This is pure orange. Okay, we have four colors in our in the cables. We are going to use that four colors. One is orange, green, blue, and brown. Okay, so the pair will be how it looks. One is orange, white, green, blue, white, blue, and brown, white, brown. So this also we have that how we have to pair it. This is the we have some rules also there. Okay, so we will see that upcoming. Okay, and this is shielded twisted pair. That means you have the shield over here. See, this is normal actually outer jacket. This is shields. Okay, this is pair shields. This is overall shields. This is unshielded twisted pair, looks like this only. Only outer jacket only will be there. Remaining will be, we have that pad with the colors. Okay. So twisted pair cable, also known as Ethernet cables, are a common type of network cable that twist two metal wires with insulation protection layer together. Currently, the most common twisted pair network cable is made of four pairs of eight wires twisted together. Cable colors orange, green, blue, brown pairs. Okay. So Ethernet cables can be divided into category 1 to category 8 based on different specifications. See, this is why they have given that each and every year or according to that. Okay, so the technology is growing up, right? So according to that, they have upgraded their cables also. So now mostly they are using this cat 5T cat 5 cables, mostly they are using it. Okay, so high end will be the up to that. Okay, so category 5 and category 8, compared to this, the category 8 will be too much cost. So according to the cost, it will be increased, and based on different specifications and performance levels, they differ in transmission rate, frequency, anti-interference ability, and are suitable for different application scenarios. Okay, so we will see what are the each cable, what is the use, how it's working. Okay, see here, this is the bandwidth rate and data rate and description and use. See, category 1, how much bandwidth it was? 750 kilohertz only. We can send voice only, used for old telephone lines and no network support. Okay, so it was before 90s. Sorry, before 2000 it was like that only. We used these cables. Okay, nowadays they are not using this. And category 2, 1 megahertz up to 4 Mbps. Early networks very slow by today's standards. Compared to nowadays network bandwidth, it was very slow only, 1 megahertz only. Then category 3, 16 megahertz up to 10 mbps, used in the 90s for basic network only, they have been used. And category 4 is 20 megahertz up to 16 mbps, slightly faster than category 3 but also outdated. This still this it is not, we are not used this cables. From here only we started using the cables. This is category 5, 100 megahertz up to 100 mbps, good for basic internet use. Now mostly outdated, this also mostly outdated. Okay, so 5e, category 5e, 100 megahertz up to 1 gbps. Okay, now we are using, mostly we are using gbps only. Okay, so improved version of category 5, common in homes. Okay, home network we are using for it. And category 6, 250 megahertz up to 10 gbps. This is great for gaming, streaming, and fast internet. And category 6A, 500 megahertz up to 10 gbps, better shielding and performance over longer distance. Okay, so according to that bandwidth and speed and the usage, the cable type is differing. Okay, and category 7, 600 megahertz and up to 40 gbps. This is used in offices, high speed and well shielded. Category 8, 2000 megahertz up to 25 to 40 gbps, super fast, used in data centers and servers. Mostly they will be using for the firewalls, data centers, all those places they will be using for information about this cables only. Okay, so same thing, but two slides I have been added. Okay, next is coaxial cable. Okay, we have seen that twisted pair cable, now coaxial cable. The twisted pair cable, unshielded cable only they are using for category, here it is, category 1 to category 8. We have that unshielded twisted pair also, it's there. Okay, unshielded UTP cables are there. Okay, and another one is twisted pair. Okay, shielded twisted pair, that starts from category 5. This many cables only, shielded twisted pair. Okay, so this category 1 to category 8, unshielded twisted pair also available. Twisted shielded twisted pair available from category 5 to category 8 only. Okay. And coaxial cable. Coaxial cable we used for our TV. Okay, so this is dish antenna we used for this cable. Okay, coaxial cables are a commonly used transmission medium composed of inner conductor, insulator, metallic shield. Okay, and sheath used for transmitting low loss, high frequency electric signals. We used for that. Okay, coaxial cable. We have different types of coaxial cables are available. Okay, and fiber optic cable. In fiber optic cable, okay, we have single mode and multi mode. We have two options all there. Okay, so fiber optic cables use optical fibers as transmission media, utilizing optical pulses to transmit information and data. It is usually composed of three parts: fiber core, strength member, and outer sheath, and has the advantages of long transmission distance, fast transmission speed, and strong anti-interference ability. So mostly we are using the fiber optic cable for the long distances. Okay, so this is it has single mode and multi mode. Okay, this are all the advantages of fiber optic cable. Okay, what is the advantage? High speed and data transfer, long distance transmission without data loss, security, reliability, high bandwidth, low latency. All the advantages are there. Okay, and here single mode and multi mode. Why we are using for single mode? Those single mode is used for large distance data transmission. Okay, for example, if you are using a laser light, what will happen? It will point out and it will reach maximum end. Okay, the maximum end it will reach. You cannot define that where it's reached, but it can. Okay, so it won't the light won't shudder here over here and there. Only it's point to point only. That is single mode. Here this is the single mode, same like single mode also like this only. So the single mode fiber has a small core and dispersion. The core diameter is usually 8 to 10 micrometer only. Okay, it only allows optical signals to be transmitted in one mode. One single signal will be traveling. Only one signal will be traveling, achieving lower attention and allowing signals to travel faster and further. Okay, so used for large transmission. Okay, next is multi-mode. Multi-mode is only for short distance they are using for, because it will be reflect to this end to this end, transferring the data like that only. Okay, it's receiving like that only. So for this it will take time. It's through the reflection only it's traveling. So the light signals also traveling through the reflections only. Okay, so this was multimode fiber has a large core diameter and dispersion with a core diameter of 50 or 62.5 micrometer, allowing hundreds of modes of transmission. So suitable for short distance and low speed data transmission applications. For the reason it is getting slow, because through reflections only it's traveling. So it's taking time. And SFP port. Okay. So we have separate port in this in our router, and the firewall also we have the separate port. This is the SFT port. SFP port. Okay, so why we are adding this port? This port around this cost around this only one port cost around 25K. Okay, so for the when they are using for the firewall servers for the fast transmission, they will be using for this SFP port. Okay, they have that here. It has that RJ45 connector. Through that they can connect. Here it is. Through then they can connect through here the router. Okay. So an SFP port is a slot on a network device or computer into which small form factor pluggable transceivers are inserted. An SFP transceiver, also known as a SFP module, is a just hot swappable pinky-sized metal component that, when connected to another device using a cable allows for the transmission of data. It allows to same the transmission of data, but it is very fast. While you are using this one, it compared normally you have a connector. This is RJ45 port only. Okay, this is RJ45 port only. Compared to this is separate port. Okay, SFP port will be separate. Through the SFP device, through that only you can connect that RJ45. So this time you won't connect a RJ45 directly through the SFP port you are connecting, so it will be very fast. Okay, so here the difference between that SFP port and RJ45. Okay, so what is the difference? Typically support to 1 Gbps to or 10 Gbps. Okay, here, this is speed and performance. Here, 1 Gbps up to 10 Gbps depending on the SFP module. Same, but this is more than that also it will work. The speed will be increasing. And distance generally up to 100 meters when using twisted pair copper cables. Okay, so up to 100 meters. Here you can cover much greater distance up to several kilometers with fiber optics. Okay, so mostly they will be using for the longer distance. Okay, and this is flexibility and scalability. Less flexible, they are fixed on to the type of cable and speed they support. Offer greater flexibility because modules can be swapped to change media or speed. Okay, so according to that speed, the flexible also will be there. And installation and cost, simpler and less costly to install and maintain. Here the installation higher initial cost because the SSP port, each port has a 25K. If you need lot of SFP port, the amount will be increasing according to that. Higher initial cost due to the need for purchasing specific SFP modules and potentially more expensive cabling. Okay. And ideal use, office environments, residential applications, on scenarios where high speed, long distance data transmission is not critical. So normally LAN man we can use it for this, and better suited for enterprise environments, data centers, and industrial applications where there is a need for high speed data transfer over long distance and versatile network configurations. Okay, so for this purpose, they will be using for the SFP port. Okay, if you go to the biggest companies, they will be everyone using this SFP port only because that data transmission also very fast. Everyone need fast transmission, right? So for this purpose, they will be using the SFP port only. Okay, so we have two types of cables are there. Okay, so we are going to use it for our devices to connect the devices. One is straight through cable, another one is crossover cable. Okay, nowadays mostly everyone using that crossover cable only. Okay, so but we have to understand which cable mostly they are using for it. Okay, so straight through cables are needed to connect switch port to a router or host. It is used to connect different types of devices. This is your understand the Ethernet patch cable. That means straight through cable means different uh, types of device. For example,